Hi everyone, in this video I'd like to start working on slightly messier transformations of sine and cosine. So we'll have more transformations in the mix for starters. So this one I am imagining a sine wave, and I see a vertical stretch by 4, which means my amplitude will end up being 4. So from the center, on the original graph, the center is the x-axis. We normally go up and down 1 unit to hit the top and the bottom. Now we'll have to go up and down 4 units. So this is quite a bit taller. Goes way up and way down and way up. Okay, and then we have what seems like a really bad plan. This is horizontal compression by 1 over 2 pi. So this is vertical stretch by 4 and horizontal compression by 1 over 2 pi. So sounds awful, but if you think about the normal, like our period and where we put our tick marks, dividing pi out of all of that actually works out really nicely. So what happens here is your period is normally 2 pi. If you compress it by 1 over 2 pi, you're just going to end up with a period of 1. So that whole 2 pi over b, if b is also 2 pi, then 2 pi divided by 2 pi is just 1. So we get a nice period, 1, no pi's involved at all. I don't see any phase shift. There's nothing added or subtracted with our x's, but there is this shift up, which means our equilibrium will end up being at 4. Okay, so equilibrium at 4, let's see. So I'm going to give myself lots of room up at the top. Okay, so there's my x, and there's my y. And I'm going to say this is 2, 4, 6, 8. Okay, and then period is 1, so let's see. Our quarter of a period is just going to be plain old 1/4, so that would make really nice tick marks. And you can make this 1/4 or this, it doesn't matter, just make sure you can fit a couple periods in here. So 1/4, 2/4 is 1/2, 3/4, and 1. And then they're negatives, -1. Okay, so we are expecting the middle, the equilibrium, to be a 4, so it's vertical center. The maximum should be up at 8, and the minimum should be at 0. So see, let's follow this 1 point through and make sure we're in the right spot. So 0, 0, if I stretch vertically, stays the same. 4 times 0 is still 0. If I compress, stays the same. 0 divided by 2 pi is still 0. If I shift up, it will move up as well. So again, what we're seeing is our y-intercept for our original sine wave was in equilibrium. And since we don't have any horizontal shift, it's still in equilibrium. I haven't flipped, so I do expect to head up from there, just like I was to begin with. So from here, we're going to go a quarter of a period, which is 1/4, and that should get us from the middle to the top of our graph. And then another quarter period should get us back to the middle. And then another quarter should get us down to the bottom. And then one more should get us back to the middle. And the same should happen here. So we should go bottom, middle, top, middle. Okay, so there's my sine wave. And then let's do a messy cosine as well. So cosine, we have -1/6. So we have a flip. It's a flip upside down. It's out in front of the cosine function, so it'll flip our y's. This is a vertical compression. So this one's going to have a really tiny amplitude. My amplitude is going to be 1/6. So our y's are only going to go up and down 1/6 from the middle. And we're thinking cosine wave. So this is the picture we're starting with. Okay, so it's an upside down cosine wave. And then it's really short, so instead of this being -1 to 1, it'll end up being -1/6 to 1/6. Even that looks a little tall, but just to get the idea. And then I also have horizontal compression. So my period, instead of being 2 pi, will be 2 pi divided by 4, which is the same as a pi over 2. So period is pi over 2. So now it's also really small this way. This, instead of being 2 pi, will be pi over 2. And then I think last thing here is the shift, but we do have to be a little careful. Shoot, I put stuff all over in the way. We need the factoring to happen here. So if we do our -1/6 cosine, we factor out the 4, and we get x minus pi over 16. So we're shifting to the right pi over 16. So we do have a phase shift. Since it's right pi over 16, I'm going to say the phase shift is positive pi over 16. If it was left, I would say negative. Equilibrium, since there's no plus anything at the end, it's a +0, so equilibrium equals 0. Okay, so let's see. I'm going to go ahead and put my x-axis in the middle then. Middle-ish, is that the middle? And y. Okay, so let's follow the point 0, 1, if I can get that in the right order. Okay, so I flip upside down, and it's going to be 0, -1. And then I compress, and it's 0, -1/6. And then I compress horizontally, which doesn't change the 0. And then I shift to the right pi over 16, so it should land at pi over 16 -1/6. Okay, so pi over 16 -1/6. Let's see, if my period is pi over 2, I would generally say a fourth of that is a pi over 8. So I'm going to make my tick marks every pi over 8. So we'll go like this, pi over 8, pi over 4. So that's 2 pi over 8, 3 pi over 8, and then 4 pi over 8 is a pi over 2, and then similarly on this side. Okay, so we know that the top of our graph should be at 1/6. So let's just say this is 1/6. So in your head, you should be aware that it's really little, but we can zoom in so that it's not unmanageable to try and graph it. Okay, so we're starting at pi over 16, which is going to be right here. Half of a pi over 8 is a pi over 16. And we're starting at a minimum. So that's pi over 16 -1/6. And then if we go a quarter of a period, which is pi over 8, so over 1, 2 of these, we should be back up to equilibrium. And then over another pi over 8 should get us to the top. And then another pi over 8 should get us back to the middle. And that should also continue this way. So we go middle, top, middle, bottom. Okay, so like this. So it's really little, scrunched both ways, especially vertically. Okay, so something like that looks like about 2 full periods. So following that first point is really key, making sure you start there. And then if you've done that very carefully, going to the quarter of your period business can make it really quick to trace those out. Okay, thanks for watching.